As Kalpana Chawla, the celebrated women astronaut, rightly said, when you look at the stars and the galaxy, you feel that you are not just from any piece of land, but from solar system. Good evening, everyone. I, Jayashri, your host for today's event, stand before you to welcome all of you to this momentous occasion. Space Talk with NASA Women Scientists. Let us go with the tradition of beginning an event with a positive note. I invite Mrs. Ashwini, Mrs. Suma, and Ms. Tridha for rendering the college anthem.
ವಂದೇ ಭಾವದ ಮನುಜರು ನಾವು ಒಂದಾಗಿ ಸಾಗೋಣ, ಅಮ್ಮಣ್ಣಿ ಸಂಸ್ಥೆಯ ವಿದ್ಯೆಯ ಜೊತೆಗೆ ಬದುಕಲು ಕಲಿಯೋಣ. ವಂದೇ ಭಾವದ ಮನುಜರು ನಾವು ಒಂದಾಗಿ ಸಾಗೋಣ, ಅಮ್ಮಣ್ಣಿ ಸಂಸ್ಥೆಯ ವಿದ್ಯೆಯ ಜೊತೆಗೆ ಬದುಕಲು ಕಲಿಯೋಣ. ಜ್ಞಾನದ ದೇವಿಗೆ ಕರದಲ್ಲಿ ಧರಿಸಿ ಕತ್ತಲು ಸರಿಸೋಣ, ದೇಶದ ಪ್ರಗತಿಗೆ ಜ್ಞಾನದ ಕೊಡುಗೆಯ ಸೇರುತ್ತ ನೀಡೋಣ. ಅರಸು ಆಶ್ರಯ KNV ಶಾಸ್ತ್ರಿಯ ಸೇವೆಯ ಸ್ಮರಿಸೋಣ, ಹಿಂದಿನ ಸಾಧಕ ಮಾರ್ಗದಿಂದಲೇ ಸ್ಫೂರ್ತಿಯ ಪಡೆಯೋಣ. ಒಂದೇ ಭಾವದ ಮನುಜರು ನಾವು ಒಂದಾಗಿ ಸಾಗೋಣ, ಮಹಿಳೆಯ ಶಕ್ತಿಯ ಉತ್ತುಂಗವನ್ನು ಸಾಧಿಸಿ ತೋರೋಣ. ಶಾಂತಿಯ ಮಂತ್ರದ ನೂತನ ಚಿಂತನೆ ಹೃದಯದಿ ಹರಸೋಣ, ನೀಲಿಯ ನಂತವ ಗುಲಾಬಿ ವಿದುವನು ಎಲ್ಲೆಡೆ ಹರಡೋಣ. ಪೀತವರ್ಣದಿ ಲಕ್ಷ್ಮಿ ಸರಸ್ವತಿ ಆತ್ಮದಿ ಬೆರೆಯೋಣ. ಒಂದೇ ಭಾವದ ಮನುಜರು ನಾವು ಒಂದಾಗಿ ಸಾಗೋಣ, ಹೊಸ ಹೊಸ ಚಿಂತನೆ ಬಗೆ ಬಗೆ ಯೋಜನೆ ಜ್ಞಾನದಿ ಬೆಳೆಯೋಣ. ಬನ್ನಿರಿ ಎಲ್ಲರೂ ಕುಲ ಮತ ಮರೆತು ಬೆರೆಯುತ್ತ ಹಾಡೋಣ, ದೇಶ ಸೇವೆಯೇ ಈಶ ಸೇವೆ ಎಂಬ ನಾನುಡಿಯೊಪ್ಪೋಣ. ಶೀಲಂ ಪರಮ ಭೂಷಣವೆಂಬ ಘೋಷಣೆ ಸಾರೋಣ, ಶೀಲಂ ಪರಮ ಭೂಷಣವೆಂಬ ಘೋಷಣೆ ಸಾರೋಣ. ಶೀಲಂ ಪರಮ ಭೂಷಣವೆಂಬ ಘೋಷಣೆ ಸಾರೋಣ, ಘೋಷಣೆ ಸಾರೋಣ, ಘೋಷಣೆ ಸಾರೋಣ, ಘೋಷಣೆ ಸಾರೋಣ. ಥ್ಯಾಂಕ್ ಯು.
Thank you. Yuri Gagarin says, orbiting Earth in a spaceship, I saw how beautiful our planet is. People, let us preserve and increase this beauty, not destroy it. Now let me invite Dr. Nagalakshmi BN, Principal MLAC, to formally welcome the gathering.
Ladies and gentlemen, good afternoon and a warm welcome to Maharani Lakshmi Ammani College for Women, Autonomous, a leading premier institution established in 1972 by the esteemed historian late Dr. KNV Shastri with a noble mission of empowering women through education for character formation. With a proud legacy of 52 years, we have been dedicated to catering to the needs of socio-economically disadvantaged students, with about 25% of our students being first-generation learners. On behalf of our management, it gives me immense pleasure to extend a heartfelt welcome to all of you gathered here for the NASA Student Outreach Program featuring esteemed women scientists from NASA. Today marks a significant milestone in our journey towards scientific excellence and educational enrichment. I would like to express our sincere gratitude to the US Consulate General, Ms. Roshni Jacob and Ms. Hemalata for their invaluable support and collaboration in making this event possible. A special welcome is extended to the students who have traveled all the way from Chennai to participate in this program. Your dedication, to expanding your horizons and pursuing knowledge is truly inspiring, and we are thrilled to have you join us today. This outreach program underscores our shared commitment to nurturing the next generation of scientific innovators and explorers. As the principal of Maharani Lakshmi Ammani College for Women, I take great pride in witnessing our institution playing a pivotal role in providing such enriching opportunities for our students. I encourage each one of you to seize this experience, to ask questions, to explore new ideas, and to embrace the spirit of curiosity and discover that propels scientific progress forward. We are committed to fostering an environment that celebrates diversity and excellence in STEM. Once again, a warm welcome to our distinguished guest, NASA woman scientist, Dr. Nicola Fox, NASA Associate Administrator. Hearty welcome, ma'am. Hearty welcome to Dr. Karen M. Saint Germain, NASA Earth Science Director. I once again welcome all participants from different schools, colleges, faculty and volunteers. A special welcome is extended once again to the students who have traveled from Chennai to participate in this program. Let us embark on this journey together, fueled by our shared passion for science and exploration. Thank you.
Thank you, Madam. I deem it as my privilege to extend my heartfelt welcome to you also. Now I call upon Mr. Akshay S., Assistant Professor, Department of Physics, MLAC, to introduce the distinguished guest, Dr. Nicola Fox.
Good afternoon all. I deem it my privilege to introduce Dr. Nicola Fox, NASA Associate Administrator, through the quote. The key to being a scientist is to love asking questions. If you are fascinated about how and why things work, you are already a scientist. Dr. Fox graduated from the Imperial College of Science, Technology and Medicine in London with a BS in Physics. She received an MS in Telematics and Satellite Communications from the University of Surrey. She then returned to Imperial College to complete a PhD in Space and Atmospheric Physics. Dr. Fox worked at the Applied Physics Lab at the Johns Hopkins University, where she was the chief scientist for heliophysics, as well as the project scientist for NASA's Parker Solar Probe, humanity's first mission to a star. Dr. Fox served as the deputy project scientist for the Van Allen probes and the operations scientist for the International Solar Terrestrial Physics Program. Dr. Fox joined NASA in 2018 as director of the Heliophysics Division, where she led a world-class team in understanding Earth's most important and life-sustaining star. As the Associate Administrator for the Science Mission Directorate, Dr. Nicola Fox directs nearly 100 NASA missions to explore the secrets of the universe. She is responsible for fostering an inclusive, welcoming atmosphere and supporting a diverse team of space scientists and engineers around the globe. As the Associate Administrator, Dr. Fox creates a balanced portfolio of carefully chosen missions and research goals to enable a deep scientific understanding of Earth, the Sun, and the universe. Dr. Fox has authored numerous scientific articles and papers, in addition to delivering science presentations worldwide. She is known for her keen ability to make science accessible to a broad range of audience, as well as her stellar leadership, creating a sense of purpose and belonging in her teams. In 2021, she was awarded the American Astronautical Society's Carl Sagan Memorial Award for her demonstrated leadership in the field of heliophysics. In 2020, she was awarded NASA's Outstanding Leadership Medal. On behalf of MLAC, I heartily welcome you for the NASA Student Outreach Program. Thank you.
All right, good afternoon. It is such a pleasure to be here, and thank you so much for coming to meet with me today. I must say I was kind of reminded of my own. Let's see. Is that going to go? Maybe. Well, I'll just keep chatting. So I was reminded of, so I went to an all-girls school up until when I was 18. And I loved that. Thank you very much for singing your anthem and singing it very beautifully, by the way. We used to start most of our gatherings by singing usually a hymn, but it was always something that we did together. So music and, sort of learning and having that inclusive environment was something that was very natural to me. So it's really wonderful to be here. Thank you to there we go. Thank you to the students that I've already met. I'm hoping to maybe get to meet a few of you also afterwards. But what you're doing here is really, really impressive. And in case you don't know, you have 4 special guests here today who have won a prize in aeronautics and are going on to actually compete in the All India. Where are they? Are they here? Are they in the room? There you are. Can you stand up so everybody can see you? I'm sure that you'll be getting to hear a lot more about them. Thank you so much. Thank you for being here. And it was really great seeing the studies that you're doing, learning about the missions that we have on the planet Mars. And also I saw a very cool way to learn how to park a car. So I'm really excited to hear more about what you're doing. But anyway, so hopefully we'll get the presentation up. But I did, as I said, I started at an all-girls school. And my fascination with space, just like everything space, I think has always been with me. When I was just 8 months old, Neil Armstrong landed on the moon. And while, of course, I don't remember it because I was just a little baby, my father wanted me to know kind of where I was when this amazing thing happened. And so he took me out of my crib, propped me up in front of the family TV, and told me what was happening. And so he totally takes all credit for me being interested in space. But it was always something that I really loved. I loved to do science, and as you said, for me, being a scientist is not about being the smartest person in the room, nor is it about having all of the answers. The thing that makes you a scientist is the fact that you're very curious, thank you, and that you want to know more about what is happening around you. So the most important thing about being a scientist is loving asking questions. And as long as you ask a question and you do that, you're already a scientist. If I said to you, what time is it? This is a science experiment, because I will say to you, what time is it? The first thing you do is you look around for something that you can use to give me the answer. You probably look at your watch. You look at it, you gather the data, you make an informed decision, and you present me your result. That's the scientific method, and we all use it every day. So as I said, I went to an all-girls school. I studied physics and chemistry and mathematics, and then I went to college, where it was mostly a male college, only about maybe 15% women in the classes. And I actually struggled when I first went to college. Let's see if this is... Yep, there we go. I actually struggled when I first went to college because I was very intimidated by all of the people around me, and I worried that if I asked a question, people would think I was stupid. And so I didn't ask the questions, and I sat there in silence, and so I struggled through college because I wasn't brave enough to ask the question. And so what I would definitely say to you is always ask the questions, because I guarantee when you ask questions, at least 50% of the other people in the room had the same question, but maybe they weren't brave enough to ask it. So always be the one that asks the questions. If you don't understand, always ask so that you do understand. So I thought, I was going to be a scientist, and I went to college. I struggled, so I thought maybe I wasn't a scientist. Maybe I wasn't cut out to being a scientist. So I went and I did a master's in engineering. And when I got to my master's course, I found that my professors would tell me, Nikki, you ask the wrong questions. Now, I would tell you there's no such thing as the wrong question. But they said to me, you think about why and not how. You're a scientist, not an engineer. You come at the problem from a scientific way. So I went back to Imperial College and I did my PhD, and I found myself in a very, very inclusive and supportive group. And so instead of being in a very highly competitive group when I did my first degree, I was in a group of people that really wanted everyone around them to succeed. And so I've even from the short time I've spent here, I can already feel what an inclusive and what a very nurturing environment that you are lucky enough to find yourselves in. So really embrace that and kind of use it as you move forward. My sort of dream job of working at NASA came about because, just like many of you were just showing me your work, I was at a conference and I was excitedly talking about the work I was doing for my PhD, and a senior scientist said, could I interest you in applying for a postdoc at NASA? Now, I didn't even know, I grew up in England, I didn't know that was possible. And so there are international postdocs that you can do with NASA. It's called the NASA Postdoc Program. And if any of you think that once you've done your PhDs, you're interested, then please look at it, apply, and maybe you too can come and do a postdoc with us at NASA. But while I've been at NASA, I have done a lot of very exciting and interesting things. I won't go through my bio because the introduction did such a nice job. But I did work with the NASA's Parker Solar Probe mission, which is definitely, I say I love all of my children equally. But that one is always really close to my heart because it was the one that I worked on and I actually got to see it launch. But I really enjoyed being at NASA headquarters. I first started off as the director of heliophysics. Heliophysics, as I'm sure you guys know, is the study of the sun and everything that the sun influences. So it's how it influences our planet here, which of course is the thing that we care about the most, but then how it influences all of the planets in the solar system, and how it in fact protects our entire solar system from stuff in interstellar space. So it's a really exciting field. And then just over a year ago, I just celebrated my 1-year anniversary as the head of science for NASA. And in this role, I get to do not just heliophysics, but also astrophysics, which I know a lot of you study, earth science, and I have my wonderful earth science director with me today. Karen, yes. And planetary science, and then also something biological and physical sciences. So that is, I'm going to tell you a little bit more about that, but that's basically how we live and adapt and how we do studies in microgravity, so outside the Earth's atmosphere. So at any one time, this is our NASA fleet. This is all of the different missions that we have, and you can see they're color-coded, so you can see which ones are planetary. They're purple. Earth, of course, is green. Blue for astrophysics. You can see the heliophysics in yellow, and then biological and physical sciences in orange there. Most of their experiments are on the International Space Station. So at any one time, we have over 140 different missions. They are in different stages. Some are still being designed. So that we're still doing all that initial work that is so crucial, and some of them have been up in space for a long, long time. So I want you to think: does anyone know the oldest NASA space mission? You can nod. Voyager, yes, very good. Voyagers 1 and 2 that have actually have passed all of the planets and are now out. They've gone beyond the protective bubble of our sun, and they're out in the interstellar medium. Also, Hubble, the Hubble Space Telescope's been up over 25 years, taking incredible views of our universe. So all different things, looking at all different aspects. And I'm going to kind of touch on, just give you some examples of each one of the disciplines. And my favorite place to start, because it is the most important planet, is Earth. Actually, but before I do, I should have just done this one first. They are our five different disciplines that we use, and you can see that each of them actually have they intersect. So there's a lot of work that we do in one division that really is sort of hand in hand with what we do with other divisions. And there's just a couple of examples up there with heliophysics and planetary science, looking at how the solar wind, how this atmosphere that continually streams off our star, how it impacts all of the different planets. Exoplanets, and that's the study of looking for planets that are orbiting another star, because of course our goal is to find planets that could actually support life. Between earth science and biological and physical sciences, we do a lot of work looking at plants, how they adapt in space, and how we can better adapt them to grow here on Earth. And then biological and physical sciences doing something called space weather, so looking at how the sun actually impacts us here at Earth. So back to my original point, that the most important planet, so I often ask people, what's your favorite planet in the solar system? And I often hear Mars, because we're doing a lot of exploration. Venus, Saturn, because it has the rings. But the most important planet for us, of course, is our own planet, because it is where we live. It's important not just because of where we live, but if you think about it, every person and everything that you know throughout history has been on this planet. And so it is an incredibly important planet for us. It is our home, and we need to take care of it. And the way that we study the interactions and the way that we study the changes in our own planet is very much rooted in our Earth Science division. Earth Science has 26 missions that are currently on orbit, sort of putting together all different aspects of Earth science and climate research to enable us to really understand our planet and protect it, because it is our home. The data that you're looking at here are actually taken from a 20-year record from instruments on our Terra and Aqua spacecraft. All of the data that we produce in our Earth Science, actually all of our NASA data, are completely open, and we publish it so that we welcome everybody coming and kind of using the data with us and doing our scientific studies. We have a sort of a great way that you can do this. It's called the Earth Information Center. And if you go to earth.gov, G-O-W, so the planet earth.gov, G-O-W, sorry, I haven't had much sleep. Clearly I can't spell anymore, G-O-V, earth.gov, you can actually see our sort of virtual portal into how we're putting together all of the different Earth science missions that we have. You can see videos that will tell you about the applications and how we use the data, and you can actually get access to the data to kind of help us. One mission I'm excited about is one we launched just last month called PACE, and that I can tell you they will be putting their first light data out later this year, hopefully late spring, early summer. I did get a sneak peek at some of the data the other day, and I can tell you, if you ever wonder whether our planet is beautiful, wait till you see the data from PACE. It will be mind-blowing for you. But PACE looks at sort of two different aspects of climate. It looks at the health of our oceans. So it looks at tiny organisms called phytoplankton, which are just incredible little organisms that live in the ocean that actually take carbon dioxide out of our atmosphere and replace it with oxygen. They're also kind of the superfood of the ocean. They're the very bottom of the food chain. And so, all of the other fish and all of the mammals in all sort of start by eating phytoplankton. So understanding if phytoplankton are healthy, sometimes they can be harmful, which can affect drinking water and can affect the fish that we eat. We really want to understand that. It also tells us about the overall health of our planet. And then the other aspect of PACE is looking at aerosols. So it's looking at things that are kind of suspended in the atmosphere, mostly in clouds. That also tells us about how clean the air we breathe is. So very excited about PACE, but the mission I am most excited about right now is NISAR, and I'm going to get the very great privilege tomorrow of going to meet with the NISAR team and see NISAR in the clean room. And I can tell you, when you see a piece of technology and it looks like that, and then you realize it's going to go to space, it's mind-blowing. And I see this all the time, and it doesn't matter how many I see, I still get like almost tears in my eyes when I see this amazing technology that's going to go to space. So this is at ISRO, and it is a partnership between NASA and ISRO. So we're very excited. This is the first sort of big flagship mission that the two agencies have done together. And it is a very clever technique. It is using two different kinds of radar, L-band and S-band, if you're interested in that, to sort of put together the picture to allow us to look at changes in our planet's surface that are just about a centimeter big. Now, if you think how big our planet is, and we are going to be able to resolve changes in the surface of about a centimeter, that is amazing. So that will let us look at just like how our surface is changing. So that's one of the core things that we care about in earth science, is sort of looking at Earth's crustal deformation, looking at kind of our ecosystems and the ecology, and looking at like cryosphere studies. The great partnership with ISRO is they had very complementary science they wanted to do and really, really important applications for the data. So taking the data and doing science is really fun, but the thing that makes it really critical is when we can use the data and the results we have to help, like, you know, our communities, our civilization. And so, you know, looking at things like agriculture studies, looking at soil moisture, looking at you know, the Himalayan glaciers and how, you know, studying those, looking at how our coasts are changing in particular, looking at, you know, the coastal winds and how the very edge of our coasts are changing. So really excited about NISAR. Of course, the data from that will also be available through our Earth Information System shortly after it launches. So really could not be more excited about being here and getting to meet with the team, as I say, tomorrow. So I mentioned that we do a lot of science just sort of off the planet. So our biological and physical sciences, they have sort of two main aspects. They do a lot of quantum science, so things that, you know, studying almost like suspending atoms and being able to study single atoms is something we can do on the space station, because we have very little gravity. It's very, very microgravity up there. And also we can get it down to super, super, super cold temperatures such that you can actually suspend an atom. The other thing we really care about is helping people get ready to sort of adapt to live in space. You know, some of you mentioned just before the importance of studying Mars, because our ultimate goal is sending humans to Mars. It's a long journey to Mars. You know, it's a difficult journey to the moon, but it's actually only a few days away. To get to Mars takes months and months. And so we want to learn about how the human body can adapt to extended periods in zero gravity, as well as the radiation that we will experience in space. So a large part of what the biological and physical sciences do is look at things like, how do we make our food sort of adaptable and sustainable and kind of more hardy, more rugged, so that it can actually survive in space. We frequently send up experiments to the space station, and what you're looking at behind me is two that we recently sent up. The one on the left is actually a metal 3D printer that was designed. It's going to go up, and we're going to look at how to 3D print metallic things in zero gravity. This is super important if you need to create a component or mend something, and you need to create actually we can 3D print tools as well as 3D printing pieces that we might need to actually use on our way. Also looking at something called adaptive machinery, so how we can sort of put more smarts inside the components. And then the other is a partnership we have with industry, a company called Redwire, and they are looking at the effect of zero gravity on very thin films. And so, how, again, as we want to manufacture and be sustainable in space, it's really important we understand how very low gravity affects the processes we do. So that's some of the things that we do in biological and physical sciences. They also do a lot of medical research, by the way. So things like they're flying, basically like they're growing like sort of replicas of human organs on chips that are about the size of a USB flash drive that you have for your computer. They're about that big, and they can grow samples of these tissues and then send them up to space and do kind of medical experiments on them. And it's you may wonder why we just don't do it here on the ground. When you take a tissue out of your body, it behaves very differently in a lab on Earth than it does inside your own body. But it behaves very similarly in zero gravity to how it behaves in your own body. So by taking samples up and testing them in space, we can do things like, look for cures for diseases, and then also, again, look for, if you were going to go on a long journey to Mars, we want you to take the exact perfect medical kit with you that is kind of the things that work for your body. Sometimes people say, if I take this, I have a headache. If I take this medication, it doesn't do anything for my headache. I always have to take, brand B. And someone else will say, I don't know what you're talking about. That doesn't work for my headache. People's bodies adapt to medication very differently. And so by actually targeting and taking tissues of like an actual astronaut and taking them up to space, we can figure out the best way to keep them safe on a long journey in space. It's pretty cool, huh? So heliophysics, the study of the sun, that was the thing that I did. That's the thing that I'm probably maybe not the most excited about, but still very excited about. So it is studying our star. One of the very cool things about heliophysics is the sun is a star, and while it is hard to get a mission to the sun, and it took 60 years from somebody saying, hey, this would be a great idea, to us actually launching it, because it's really hard to do. It's much easier to go and visit the sun than it is to go visit another star. So, by going and studying our sun, it helps us be able to sort of figure out how other stars would behave in other stellar systems. So this is critical as we want to look for places in the universe that maybe could also sustain life. You need to understand what a star and how it behaves that sustains life. We often refer to our sun as an ordinary star, because it's, if you think about that sequence that you draw in your astrophysics class, the sun is kind of right in the middle of that, because it's an ordinary star. But it's the only star we know that currently sustains life. So it may be an ordinary star, but it's a pretty special ordinary star. So we want to be able to understand it. The other reason that we want to study the sun is you may have noticed recently that the sun has become very active. It's moving up to the maximum phase of the solar cycle. Our sun has about an 11-year cycle, and we are moving up either very late this year or sort of somewhere between late this year and the middle of next year. We will be at the maximum phase. That means that lots and lots of flares are coming off the sun, and they can carry with them billions of tons of solar material accelerated at millions of miles an hour. If our planet is in the direct line of that event, then that increased activity will come into our magnetosphere. So the Earth is protected, obviously, by our magnetic field, but this energy can enter into our magnetosphere, get it really excited. It can cause beautiful things like aurora, but it can also cause power grid issues. It can cause problems for spacecraft on orbits, and so we really do need to make sure we understand our star so we can better predict when we might have issues here. So that's what we do in heliophysics. I'm hoping that you sort of watched in September of last year as we returned samples from an asteroid. So this is the capsule that came down. So this was the OSIRIS-REx mission, and it returned samples from an asteroid called Bennu. It was an amazing mission. The samples are now back here, of course, on Earth. I did get to see some of the samples just 2 weeks ago when I was at Johnson Space Center. We brought back just over 120 grams of this incredible sample. We've already found surprises in the sample. They found carbon and they found water, which of course are the building blocks of life. Bennu is a very old asteroid. It was around at the time of the Big Bang, so it was around the time that our solar system was forming. And so we hope by studying this very, very ancient sample that we can sort of figure out what life was like as our planet and our moon were forming. It's hard to do that here on Earth because life has started on Earth. And as a species, life is very noisy. And we've caused a lot of changes on our planet. So it's very hard to find conditions that would be sort of the same as when life, kind of before life formed. So it's really interesting to have these samples back. I will also note, getting back to the PACE mission and how all of our missions kind of work together, we know that all life started in the oceans. And so by studying the oceans with PACE, we're also contributing to kind of the factors that would be necessary to sustain life on another planet in another stellar system. So you can see how they all line up together. But OSIRIS-REx was only one of several sort of asteroid anniversaries we had. We called it Asteroid Autumn because we had all of these things happening at the same time. Just shortly after the capsules came back from the OSIRIS-REx capsule came back, we launched Psyche, which is also an asteroid mission, but a very different one. Psyche will go to a very unusual asteroid. It is a metallic asteroid. We only know of 8 that are around in our solar system. Psyche is actually the largest of them. But we're hoping by studying that we might learn about the cores of planets. That if you think the core of a planet is very metallic, and so how did that get there? How did it coalesce there? So by studying Psyche, we're hoping to learn more about these very different types of asteroids, but also how planet cores formed. Also in the fall, another asteroid mission, Lucy, flew past the first asteroid. Now, Lucy is going to go out and study Trojan asteroids. So they are the ones that are sort of in Jupiter's orbit. Lucy will fly by an unbelievable amount of asteroids. I think 4 in the main belt, and then I think 12 in the Trojan region. So looking at all different types of asteroids. So Lucy flew past the first one in the fall. It's called Dinkinesh. And we thought this was a fairly ordinary asteroid. When we did the flyby, we found it was actually a binary asteroid, so 2 stuck together, kind of orbiting around one another. So also showing the importance of going to visit these things and not just imaging them here at Earth. And then the final anniversary we had was the 1-year anniversary of DART. And DART was a demonstration of how it's our planetary defense. If we needed to, could we redirect an asteroid? So if something was coming towards our planet, could we actually go up and impact it and change its orbit so that it would actually miss Earth? And we had a wonderful demonstration with DART that showed that we could do that. So that's just some of the things that we do in Planetary. I focused it on asteroids this time, but of course we have amazing missions at Mars. We have amazing missions throughout the whole solar system. And of course we have things that are going to be looking for water, traces of water, and traces of kind of biosignatures of things that could actually sustain life with our Europa Clipper mission that will launch later this year, and then Dragonfly that will launch in 2028. So the experiments outside that had the quadcopters with your aeronautics program, that's basically what we'll be flying at Titan, one of the moons of Saturn. It's actually an octocopter because it has 8 blades, but it will be sort of hopping around Titan, taking samples. So for those of you who are interested in chemistry, it'll be taking samples and kind of analyzing what Titan is made of and if there's water underneath that very thick crust. So lots of exciting stuff in Planetary. Also in sort of with our Planetary, we of course study the moon, and I'm sure you noticed about 2 weeks ago we actually had a landing on the moon at the South Pole. Of course, we were really excited about the ISRO mission, Chandrayaan-3, that landed last year also at the South Pole, so congratulations on that. And we're very excited to be sharing data with ISRO. This was our first attempt at landing on the moon, so this was Intuitive Machines 1, and just a spectacular shot of the lander heading down towards the moon, and that was taken from the SpaceX Falcon 9 that actually took that image. But this is a new way for us. We're working very closely with industry, with our commercial partners. They are building the lander, and we put the science on the lander. So it's enabling us to try and get more science in space for less money. So it's a really great partnership, and we're looking forward to more of these launches throughout the rest of the year. So astrophysics. This is a really nice, I could have picked so many. Obviously, we have our James Webb Telescope that we're really proud of. Last year, we celebrated kind of 1 year of full science investigations. And what you're looking at here is a partnership between the JWST mission and the Chandra X-ray mission. So JWST takes images in infrared. And so it actually it looks very differently at the same area in the universe. So if you, there's some great examples of what Hubble sees versus what JWST sees. And often people say to me, well, JWST is so much better, why do you still have Hubble? But actually, because they look at in very different wavelengths, they see very different things. So if you look at a Hubble image or even a Chandra image, often it looks dark because it's very dusty in the universe. And if you look at it in sort of, well, with Hubble, if you look at it in visible and with ultraviolet, the dust actually absorbs the light. So it looks very dark. But once the dust has absorbed the light, the visible light, it actually emits in infrared. And so so something that looks dark in Hubble looks very bright in James Webb. And when you put them together, you're seeing a full picture of what the universe looks like. So this is another great example of this, where JWST took an image of a galaxy that was billions of light years away. So it's one of the oldest galaxies that we've actually imaged. On Nancy Grace Roman, they will be able to block out the light of tiny stars, and that will help us look for planets that may be orbiting around that star as we want to look for more and more exoplanets. And so I'll kind of wrap up by saying, I love being here. This is an incredible atmosphere, a very, very supportive atmosphere. I talked about why it's important to be, we're all scientists. Some of us enjoy studying scientists, but we're all scientists at heart. And so, I really encourage you to kind of keep asking questions, keep being curious, keep enjoying what you do, and also go out and tell your communities, your local communities, about the exciting work you do and about the importance of the work that you do, because it's great. What you're doing here is great. There is a total solar eclipse that is visible in the US in this year in April, and we will be doing a big global celebration to do that. We'd like to invite you to join in what we do. So I promised a couple of you who asked me how to get involved with NASA. There are 3 Q codes up on here, and we'll make sure that we leave them for you of ways that you can get involved. So through our Heliophysics Big Year, which is what we're calling kind of the everything that we're doing with the eclipse, we have something called Citizen Science. And this is a great way for you to get involved with NASA data. So all of our NASA data are public, and we have volunteers all around the world that actually help us. A lot of them have discovered comets that we didn't see before. They've discovered really cool features in the Northern Lights. We're always looking for more people to help us with climate research. So you can learn all about the citizen science experiments that we have. You can also do something called open science training. All of our NASA data, as I say, are available, and this training will kind of help you figure out how to come in and use the NASA data. And then obviously our website, where you can find out about all of the amazing stuff that we do. So we really do encourage you to join us. In case you're interested, the next time you will see a total solar eclipse here is 2034. So it sounds a long way away now, but believe me, it'll be here before you know it. And so thank you so much for your attention, and I'm delighted to take your questions with Karen.
Thank you, Dr. Nicola. You actually took us through a journey and inspired all of us. You not only briefed about NASA's science fleet, but also introduced various aspects of biological and physical sciences. It is indeed interesting to know how vast the subject of space science is, as the space is. Thank you. I now request Ms. Hemavati E., HOD, Department of Biotechnology, to give an introduction of another distinguished scientist of the day, Dr. Karen M. St. Germain.
Thank you, Jayashree. Good afternoon. I would like to introduce our next guest with a quote from Michelle Obama. Success isn't about how much money you make, it's about the difference you make in people's lives. I, Hemavati, Head of the Department of Biotechnology, deem it an honor to introduce Dr. Karen St. Germain, a well-known, accomplished women scientist in the world space arena. Her space missions that orbit the Earth has made an impact in understanding climate change, food and agriculture for sustainable future. Dr. Karen holds a bachelor's degree in electrical engineering from the Union College and master's degree in national security strategy from the National War College, National Defense University. Dr. Karen did her Doctor of Philosophy in Electrical Engineering from the University of Massachusetts. She has shown to be a strong woman during her research career at Massachusetts, Nebraska, and the Naval Research Laboratory, where she has carried out missions in the Arctic and Antarctic regions, Greenland ice sheet, and has flown through hurricane and tropical storms on the NOAA P-3 airplanes. As an accomplished women scientist, she has held distinguished positions in various agencies such as the Space Strategy and Intelligence Systems, Director of OSAP, Deputy Assistant Administrator System for the development and deployment of the NOAA's 2 major satellite programs, the Cosmic 2 mission and the Space Weather Follow-On. She is currently the Director of the Earth Science Division, NASA headquarters, responsible for the overall management for the entire agency's Earth Science portfolio, from the technology, development, applied science, research, mission implementation, and operation. With this profile, I welcome Dr. Karen for having, and I thank you for gracing this occasion. Just one note, I have just cut down on her profile. her mission work, research work, everything that is carried out at NASA is all available on the YouTube for you to visit. Thank you.
Brand Paul says, "Don't tell me the sky is the limit where there are footprints on the moon." Well, now it is the moment where there is an opportunity that we can interact with the stars of NASA, and we can also derive a lot of inspiration from them. This interactive session would be moderated by Ms. Shambhavi, Department of Computer Science, MLAC. The session is now open for the interaction with the students.
Thank you, Jayashree.
Good afternoon, ma'am. My name is MS Nishita. Good afternoon, ma'am. My name is MS Nishita. I'm pursuing my first year BSc in Computer Science and Physics. It's an honor to meet you. Thanks for giving me an opportunity to converse with you. I have a question for Dr. Nick. What is an advice would you give for a beginner who is interested? What is a advice you will give for a beginner who wants to be a scientist? I'm sorry. What is an advice you will give for a born scientist who wants to pursue a career in space science?
Thank you. Great question. My advice is just do it. Seriously. I will tell you a career in space science is really rewarding, and a lot of the reason about that is it is an incredibly diverse sort of field. So space science, you might think of it, it's astrophysics, and that's you will interact with people who do absolutely every possible job. And if you think about putting a mission into space, there are so many roles. You can be a lawyer and work in the space business. You can be an accountant and work. You can be a graphic artist. You can be obviously all different kinds of engineers. It takes all different kinds of scientists. You know, we have all, if you like doing math and you want to do budgets, we need those people. That's how we put missions into space. So the great thing about doing space science is you don't just get stuck. It's not like you do this and you're going to do this for the rest of your life. You will be able to do so many different things. And so really whatever passion you have, you'll find that role in space science. The thing I enjoy the most, honestly, is doing what I'm doing right now, talking to people like you about what we do. And that's the thing, I get lots of opportunity to do that. And my team will tell you I very rarely say no to particularly going out to speak to schools. Just, letting you know that it is a career that you can do, and it is an incredibly rewarding career. So just do it. But study hard, study hard. My mom would always say, you can do anything you want as long as you work hard enough. And that's kind of the way I have been. You work hard and it's very, very rewarding. So keep studying, but just do it.
Thank you, ma'am. Excuse me.
Karen added, be brave, by the way. So.
Hi, good afternoon. I am Harshini, currently pursuing my final year bachelor's degree in computer application. So considering the recent rapid pace advancement in technology, I was interested in the solar expedition missions. So in such future exploration, where do you think which mission and areas of the mission will completely rely on computer applications?
Wow. I will tell you every mission every study we do really does rely on computer applications. I'm going to hand the mic to Karen in a minute, because earth science in particular relies a lot on artificial intelligence and machine learning in like every aspect. But, the Nancy Grace Roman telescope that I mentioned, that is going to look at over 1 billion galaxies in its lifetime. It's going to do this like a sort of kind of survey of the entire sky. There will be so much data that there is no way that a human could look through and find, it's just too much data. And so we will rely on machines and high computing power to sort of go through and find all the interesting things, and then our teams will say, okay, this is the thing that we're going to go look at, because it would, no one's life would be long enough to be able to look through all the data that we will produce. For the solar in particular, we rely a lot on computers to be able to help us know when an event that happens on the sun is going to really be impactful for Earth. The event itself, the radiation that comes with a flare travels at the speed of light. And so when the flare happens, 8 minutes later, you see the effect at Earth. So you have to have something that can do that computation quicker than your eyes and your brain. You also, the radiation travels at about half the speed of light, so you need to get a warning to astronauts. And then the event itself takes about 3 days. But looking at what is going to be most effective. So that's a particular one that kind of links to the sun. But Karen.
Thank you, Nikki. Thanks for the great question. And before I start, I just want to say it's a tremendous honor for me to be here with all of you. I also was a first-generation learner, so you're inspirational. In terms of computer power, and how that relates to our missions, I would say it's infused in every mission and in almost every aspect of every mission, from using computers to design our spacecraft, design our instruments, to we're investing in new computer-driven on-orbit capabilities to develop smart constellations of satellites. So we may have a satellite that sees something interesting happening on Earth. It automatically tells another satellite, go look over here with your different technology. Just as Nikki talked about the black hole and how we gain more information, more insight when we look at it with different sensors, the same is true of looking at Earth. So we're using computer technology to develop smart constellations of satellites. And then, as Nikki said, in many, many areas, we have more data than humans can digest, and even more data than traditional analytics can work through. In Earth science, today we collect 100 terabytes of data per day. And as soon as we launch NISAR, which is, of course, our partnership with India, we will nearly double that amount of data. So we have to use these new analytic techniques to just extract meaning and insight from all the data. And I will just mention one recent example using new imaging, very high spatial resolution imaging from space, and combining that with analytics, artificial intelligence. We were able to count every tree in sub-Saharan Africa and account for the carbon uptake. So as we are getting more sophisticated in our understanding of the carbon cycle, we will be relying on a compute capability to manage all of that information.
Thank you.
This will be the end of the interaction. Thank you.
Thank you, Dr. Nicola and Dr. Karen. It was very informative interaction. I request the dignitaries to join for an official photo session now.
And after that, you turn around
It's our tradition.
Thank you.
Yeah, good afternoon to all. I take this opportunity to render vote of thanks to our distinguished dignitaries. My heartfelt gratitude to our two renowned women scientists, Dr. Nikki Fox, Associate Administrator for NASA Science Mission Directorate, who inspired young minds towards STEM discipline, and Dr. Karen M. St. Germain, Division Director of Earth Science Division in Science Mission Directorate, NASA, for sharing her expertise about earth science. My heartfelt gratitude to Ms. Roshni Jacob, US Consulate General Chennai Strategy Content Manager, and her team for their coordination with MLAC in implementation of this program. I am also overwhelmed to look upon the success of 4 girl students from Tamil Nadu who made it to top 3 in National Aero Modeling Competition from South Zone. My sincere thanks to Dr. Naglakshmi B. and Principal MLAC, a pillar of strength, for leading and implementing this program to a grand success. Acknowledging the core members as well as joint coordinators for their magnanimous support and coordination. I'm grateful to the different committees, and I'm thankful to HODs and faculties of Science Department's MLAC. Last but not the least, I'm thankful to dear students from MLAC as well as outside college and school participants, and also the online viewers for their amazing learning experience. Special thanks to media and press for video coverage of the event. Have a great evening. Thank you all.